Hey, my mate, imagine that you are a recognized cardiologist and you have to work with the top two cardiologists in town. You will have three different patients with different heart problems. You are the best doctors here, but you and your team have to keep the title for the best hospital in town. For that reason, your team and you have to evaluate your performance and estimate your risks with every patient for better results. How we can solve this? Yeah, we think the same thing with the Hungarian algorithm. We have here a graph that represents relation between surgeon and patients. Subgraph A represents only surgeons and subgraph B represents patients. Every surgeon and every patient represents a vertex. We can see here the quantification for every surgery with relation surgeon-patients. For example, cardiologist 8H has 5 points in a difficult scale with 8 patients. Now, in this algorithm, we have to do 3 steps. Step 1. We are going to work with ACER graph. Here we have to choose the smallest value for every vertex, in this case for every surgeon. Then, for every value in ACER graph, we have to subtract to the values already established and we will get a new values. Step 2. Similarly to the last step, we are going to work with a subgraph, but now with B1. But first, in this step, we have to move the values that we got in the last step, with the last relation surgeon-patient obtained. In the same way, we are going to choose the smallest values for every vertex, in this case, for every patient. Then, for every value in B subgraph, we have to subtract to the values that we obtained in the last step, and we will get a new values. Step 3. As a result of this operation, we obtain these values, and we have to choose the smallest for every patient. These values are the answer to which are the surgeries with lower risk for the hospital. To conclude, we have here the final relations surgeon-patient. Cardiologist 8H with patient B with a risk of 0 units. Cardiologist BH with patient C with a risk of 0 units. Cardiologist CH with patient A with a risk of 0 units. As a result of these operations, we obtain what are the best relations between cardiologists and patients. We have to choose the smallest value for every vertex in subgraph B, and that relation is the best option for the surgeries. Now, if we return to the original values, we can see that the risk for the surgeries is the next one. The risk of all surgeries is measured on a scale from 1 to 10. Cardiologist AH with patient B with a risk of 2 units. Cardiologist BH with patient C with a risk of 7 units. Cardiologist CH with patient A with a risk of 1 unit. Now you know how can you resolve an assignment problem with a better solution.